Hello and welcome to day 2 of our sequences and series unit. Here we're going to be going over arithmetic sequences and series. All right, and if you didn't watch the first video, you can check that out in the playlist. So we're going to start off with just a warm-up. This is reminding us of what we did in the previous video. So it asks us to write down the first 4 terms of the sequence, and here they gave us the rule. So an equals 2 to the nth divided by 3 to the nth plus 1. So the first 4 terms is going to start off with a1, and remember that little subscript. 1 is saying that n equals 1. So I do 2 to the first over 3 to the first plus 1, and I'm pretty sure that's going to be 2 over 4, aka 1/2. All right, a2, so I'm doing 2 to the second over 3 to the second plus 1. That is going to be 4 over 9 plus 1, so that's 10, and that also reduces to 2/5. How nice, everything is reducing. A3, I'm going to do 2 to the third over 3 to the third plus 1, so that's going to be 8 over 27 plus 1, so 28. Oh my gosh, it reduces again. Who knew? A4, do we think it will reduce again? All right, place your bets now. Don't cheat and try to do it first. All right, we get 2 to the fourth. That's going to be 16. 3 to the fourth is 81 plus 1. That's 82. And you guessed it, it reduces to 8 over 41. So the first 4 terms of this sequence are 1/2, 2/5, 2/7, and then 8/41. And that would be miserable to try to recreate if we were trying to write what the rule was just from those numbers. So thankfully, we're not doing that. All right, let's get into the definition of what an arithmetic sequence is. So we have an arithmetic sequence is going to be when the difference between consecutive terms, so when we have terms, one after the other, is a constant, meaning that if I have a pattern here, and I'm just going to make one up, I'm just going to use a really easy one, 2, 4, 6, 8. Who do we appreciate? No? Okay, whatever. If I'm looking at this common difference, what we officially do is we do the next term minus the previous term, and that would equal 2. So if I did 4 minus 2, that would be 2. If I did 6 minus 4, that would equal 2. If I did 8 minus 6, that would equal 2. And we refer to this as the common difference, all right? And we use the letter D to represent this. So we say, hey, the common difference, D, is 2. Now, our first term for this one that I just did here, our first term would have been 2. And we write that just by, remember, saying A1 equals 2. So what's really fun about these is that every single arithmetic sequence, which is basically when you're adding something each time or subtracting something each time, you have this common difference that's happening, can be defined by this formula right here. So it says an equals a1 plus n minus 1 times d. And remember that this is our rule, okay? So we're saying this is the rule that we're following anytime it's arithmetic. And we have a1 is our first term, and then d is going to be our common difference. And this is going to stay as an, and this is going to stay as n. So it's kind of like back in the day when you had y equals mx plus b, and you would fill in, like, say, hey, m, the slope was 2/3. So you would say, like, y equals 2/3 x, and then, like, your y-intercept was -1, let's say. You left y and x in the equation, and you only figured out what m and b were. Same idea here. We're going to leave an and n in our equation, because those are basically our x's and y's in sequence notation. And then we're going to fill in a1, which is our starting value, kind of like a y-intercept, right? Because y-intercept is where we would start graphing. And then our common difference, which is actually 100% the same thing as a slope. So arithmetic are actually linear functions, which maybe we'll get into a little bit later. I want to just use my little example that I was using up here. I would write the rule for this and say it's an equals the first term, which was 2, plus n minus 1, and then my common difference was 2. And if you want to put that in parentheses, you can. We normally put it at the end for some reason, but if you really wanted to, we could have probably written this like this and put it in front, and then we wouldn't need those extra parentheses and do, 2 times n minus 1. And then if we really wanted to, we could simplify, right? We could distribute the 2. We would get 2 plus 2n minus 2. And we get 2n when we're simplified. So you are allowed to simplify these, but you're not required to when you're in sequences and series like you maybe would have been if you were in function land. So for these first 2 examples, and then your turn, we're going to try to figure out whether or not these things are arithmetic. And remember, arithmetic just means that there's a common difference between them, and that's just a really fancy way of saying that we can add or subtract the same number over and over and over. So if I look at this first one, 0, 7, 14, 21, 28, it looks like each time, wow, those are terrible, how I just tried to draw those little arcs there. Let's try that again. From 0 to 7, from 7 to 14, 14 to 21, and 21 to 28, it looks like I'm just adding 7 each time. So yes, this is arithmetic because I'm adding 7 each time. When I look at this one, 1, 3, 6, 10, 15, if I want to check specifically arithmetic, I always focus on what I'm adding. So here I added 2, but here I added 3, and then here I added 4, and here I added 5. So there's certainly a pattern that's going on here because the thing I'm adding by is increasing. Like, for example, I'm going to add 6 the next time around. So the next number after 15 is going to be 21. But I'm not adding the same number each time. So this is not arithmetic. But it certainly has a pattern that's involved in it. It's just not this very specific one that we're focusing on today, arithmetic. All right, you should pause the video and you should try to figure these ones out yourself and see if you can determine whether they're arithmetic, which means they have a common difference. Welcome back. So glad you paused the video. Awesome. Let's try to figure out whether or not these are arithmetic. And remember, that means I'm adding each time. So here I would be saying, hey, if I add 7, that would bring me from 1 to 8. If I add 7 again, does that bring me to 27? And the answer is no. I would be at 15. So this is an automatic no. You don't need to check anything else. Now, again, this does have a pattern. If I'm looking at this, this looks like numbers that are being raised to the third power. So I think the rule for this would actually be n to the third. So I think this would be one of those power sequences. So if I had my first term, n would be 1 to the third is 1, then 2 to the third is 8, 3 to the third is 27, 4 to the third, 64, and 5 to the third, 125. So that is the rule, but it is not an arithmetic one. And here, I'm hoping you figured out that it does look like we're just adding 2 each time. So our common difference would be 2, so the d value would equal 2, and that, yes, this is arithmetic. Alrighty, so now we're just going to do some examples where we practice writing the rule for things. So here, it says write the rule for the nth term, so that just means we're going to have an equals something, for this arithmetic sequence that goes 20, 18, 16, 14. And they specifically tell us it's arithmetic, so we know for a fact that it is. So we don't have to, try to figure it out. We know that it is. So the rule for an arithmetic was that big formula that we had before. an equals a1 plus n minus 1 times d. So when I look at this, a1, well, that's 20. And my common difference, it looks like I'm decreasing by 2 each time, so it'll be a negative 2. So my rule, an, is going to equal 20 plus n minus 1 times negative 2. Now, when it's a negative for the d value, you 100% must put parentheses around it, or write it in the front, and you would do 20 minus 2 times n minus 1. So this is officially our answer. I just want to sidebar off that a little bit and just show you what's going on if we simplify this. So if I simplify this, I'm going to get 20 minus 2n plus 2. And so that is going to give me, I just completely forgot how to do math for a second, but negative 2n plus 22. And so this is a simplified version of it, and this is also acceptable. But the reason I did this is I wanted to show you that this lines up with our y equals mx plus b exactly. Because remember, our an is our output, that's our y value, and our x and n are both our input values. And so when we're looking at this, negative 2, which was the d value, is our slope directly, and then b is 22. And notice how that does not line up with what our first term is. And that's because in functions, b happens when x equals 0. And in sequences, n, our x value, cannot equal 0. It goes from 1, 2, 3, 4. It can't be 0. And so that's why we have to have a different first term that's not the same thing as our y-intercept if we thought of these as functions. So that's just a little sidebar. I think it's neat to make that connection. And you can do a lot of math using it as a function. And then saying, okay, but it's really a sequence. Let me rewrite it in sequence form. Alrighty. They asked us to find an here. So before we finish this one, I'm going to find an. Remember that little n is just saying that n equals 9. So I'm going to do 20 plus n minus 1 times negative 2. And so let's see, I'm so good at math, I can do this. N minus 1, that's 8, times negative 2, that's going to be negative 16. So I'm going to get that AN equals 4. Now, you would probably have a calculator for this, and so you could use it to figure it out. But also you could do that math. All right, your turn. See if you can figure this out. You're going to write the rule for this arithmetic sequence that goes 3, 5, 7, 9, and then you're going to figure out what A12 is. So you should pause the video and figure that out. Welcome back. A1 is equal to 3. Our common difference this time is we're going up by 2. So positive 2. Our AN is going to be 3, our first term, plus N minus 1 times 2. You don't need the parentheses. I personally just always put it there just for fun. If we want to simplify this, which you don't have to, but if you wanted to, we would distribute the 2. We would end up getting that AN equals 2N plus 1. And now we've really connected again that this is linear. This is a y equals mx plus b type situation. For A12, I'm going to use the original one because honestly, I would not have simplified this if someone asked me to solve this. So I would have used the unsimplified one. So I'll get 3 plus 11 times 2, so that's going to be 22. So the 12th term in the sequence is going to be 25. Alrighty, I hope you figured that out and it's not too crazy for you. We're just going to keep doing these with different scenarios. So this next one, we're going to be given what the common difference is. So they're telling us what D is, and then they give us a very specific term. So for this first one, they said, hey, A11 equals 24. So what we need to do in order to write the rule for this is we have to first figure out what the first term is, A1, because remember, our rule, I just lost my mouse and clicked out of things. Here we go. Our rule involves knowing the first term, okay? So we need to first find the first term. And the way that we're going to do this is by actually starting off with that formula. So I have AN equals A1 plus N minus 1 times D. And then I'm going to use this, I was going to call it a point because it basically is a point. I'm going to use this term, A11 equals 24, to say, hey, remember that this is saying that N equals 11. And when N equals 11, the whole thing equals 24. So I can plug this in right here and say AN, when N is 11, is going to be 24. And then I'm letting this N value be 11. And then I have A1 I don't know. I have the minus 1 there. And then they told me what the D value was way over here. The D value was 2. So I'm going to do times 2. And so when I fill in the things here, you can see that I have an equation that only has one unknown, which is A1. I'm going to be able to figure out what this value is. So I'll have 24 equals A1 plus, so 11 minus 1 is 10 times 2 is going to be 20. And so I'm going to get that A1 equals 4. And so when I want to write the rule now, life's easy. I'm just going to say, hey, AN equals 4, the first term, plus N minus 1 times 2, because that's my common difference. And if I want to simplify it, I can. It is going to be 2n plus 2 when you do all of that math. But again, you don't need to simplify it. It just connects it back to linear functions a little bit more. And so this process is really similar to when you were in Algebra 1 and you would have a y equals mx plus b situation, and we would say, hey, m equals 2, and we know that it goes through the point 11, 24. Can you write it in this format? And you would have to go through the process of figuring out what b was by plugging in the points to the equation and plugging in the other information and solving. So it's the exact same thing. We're just using new notation now, which is sequence notation. Alrighty? So pause the video, give it a try, and come back and we'll go over it. Welcome back. For you, I bet that took about 2 seconds. For me, hours, because I had to do the your turn. Not really. I just literally kept talking. All right. Arithmetic sequence, A4 equals 10, so the fourth term is 10. Common difference, -3. So I'm going to start off. I'm going to just keep writing the rule here. You're probably going to eventually skip this part and just start plugging stuff in, but that's our rule for every arithmetic in the world. It's going to equal 10 when n equals 4. So I'm going to do 4 minus 1, and my common difference was -3 because they gave me that. So again, here's where I'm getting the 4 and the 10 from. So the 4 is what n is, and 10 is what it equals when n is 4. And then the common difference was given to me as -3. And now we just clean it up, right? So we have 10 equals A1. It's going to end up being -9 here because we're going to get 4 minus 1 is 3. 3 times -3, -9. And I'm going to add that to the other side. I'm going to get A1 actually equals 19. And so my rule, an, is going to be 19 plus n minus 1 times negative 3, and this would be my answer. And again, if you wanted to simplify it, you could. It would simplify to an equals negative 3n plus 22. And again, that's linear. So that's what I'm driving that home. Arithmetic sequences are the same idea as linear functions. They're just slightly different because their domain has to be positive integers. 1, 2, 3, 4. No decimals, no negatives, no 0. All right, here's where we get our first way that we're going to be able to do this 2 different ways. And you're going to get to pick which way you like better. So I'm going to put like a little divider right around here, I think, and hope that I don't need much more space than that. But this time they're asking us to write the rule for the arithmetic sequence, and they tell us that the 8th term is 75 and that the 20th term is 39. Okay, so this time we have no idea what the letter D is, we have no idea what A1 is, but we need both of those in order to write the rule. So we start off doing a similar thing. I'm going to say, hey, if my rule is an equals A1 plus n minus 1 times D, which you need to memorize, I'm going to start off with this first one here. Okay, the 8th term is 75. So I'm going to say, hey, 75 equals A1 plus 8 minus 1, because the 8th term is 75, times D. I'm going to do the same thing with the 20th term. So I'm going to get 39 equals A1 plus 20 minus 1 times D. And if you're looking at this, we have 2 different equations, and we have 2 different unknowns, which means we have a system of equations. So I'm just going to rewrite this to clean it up a little bit. So what that basically means is I'm just going to do the math that's in the parentheses. So I'm going to get 75 equals A1 plus 7 times D, and I'm going to get 39 equals A1 plus 19 times D. And this is set up perfectly for the elimination method of solving systems. So I'm going to subtract these. So 75 minus 39, that's going to give me 36. A1 minus A1, that's going to be 0. And then 7 minus 19, that's going to give me negative 12D. And if I solve for the letter D, I'm going to get that D equals negative 3. And then just like we did in systems, we can plug it back in and see what's going on. So if I plug this back in to the top equation, it doesn't matter which one I plug it into. I just pick this one. I'm going to get 75 equals A1 plus 7 times negative 3. So 75 equals A1 minus 21. Add that to the other side. I'm going to get A1 equals 96. I can now write the rule for this problem. So I'm going to get that an equals 96 plus n minus 1 times that common difference, negative 3. And so there we go. I'm done by just creating a system using these 2 arbitrary ways. Now, let's talk about the secondary way, because maybe you like this. I kind of want a different color, but I don't have any cool ones left. So we're just going to go back to blue. If we recall that arithmetic sequences are linear functions, right? So an arithmetic sequence is linear, and we know that the common difference is equal to the slope. Well, what if we just treated these term numbers like they were points? So let's just say I had the point 8, 75, and I had the point 20, 39. I could just find the slope, right? So we know that the slope would be 39 minus 75, y2 minus y1, over 20 minus 8, so x2 minus x1. That's going to equal 36 over negative 12, which is negative 3. And we now know the slope. And then we basically just do the same idea that we did over here to figure out what A1 is. And then once we know that, then we know the rule. So this is an alternate way of doing things if you like. My preference is that we stay in the sequence notation just because we're in sequences and series. We should just get really familiar with it. But if that's, a lot of work for you, you can fall back on using slopes if you need to. Okay, you just have to remember that this is not the same thing as y equals mx plus b. If you were to just try to do it like that, you actually have to use sequences because b is not the same thing as a1. Alrighty? You should pause the video now and you should give it a try yourself. And I will be here working on it just the same as you are. So I'm going to do the same thing. I'll show it both ways just for funsies. I'm going to take that 6th term is 32, so I'm going to have 32 equals a1 plus, and I'm doing it long-winded. My guess is that you would eventually not need to write 6 minus 1, and you could just write 5 there, but, whatevs. Same idea for the next one. I'm going to have 263 equals a1 plus 27 minus 1, okay, times d, and if I clean those up, that's going to be 32 equals a1 plus 5d, and 263 equals A1 plus 26D. All right. Again, it's set up perfectly for elimination because we can eliminate that A1 value. I'm going to use subtraction there, so I'm going to get negative 231, and that equals negative 21D. I used my fancy calculator to get that D is going to equal 11. I pick one of the equations to plug it back into. I'm going to use the top one, because I know what 5 times 11 is, right? So 5 times 11 is going to be 55. Move that to the other side, and I'm going to get negative 23. So my rule, AN equals negative 23 plus n minus 1 times 11. And that's going to be my rule. Now again, if you want to treat this like it was a function, you would do 6 comma 32. So you write that as a point, and you would do 27 comma 263. And then you would find your slope, because we know that the common difference is the same as slope. All right, so I would do 263 minus 32 over 27 minus 6. And I would get 231 over 21, aka 11. And then we would do the same process to try to figure out what A1 is. There you go. That is the basics of arithmetic sequence. And now what we're going to do is transition to working with arithmetic series. So remember that a series is a sum. So we're talking about arithmetic sums. Now, it just so happens that an arithmetic series, or a sum of arithmetic sequence, has a very specific pattern that we can use. And it's this right here. So we first have this Sn, that's saying the sum of the first n numbers in this arithmetic sequence. Can be given by this first formula here is one way of writing it. We're going to focus on this one here. Okay, and there's like a lot of math for why this works. You could figure it out if you want to, that it ends up being this way. But essentially, it always ends up being however many terms there are, divided by 2, and then times the first term and the last term that you're adding together. So n here is your total number of terms. So total number of terms. So it's not a term number, it's how many terms you have. A1 is our first term, and AN is our last term. So this is the actual number. So you have to figure out what is the last number in this. So for example, in the one right below it, part B, our first term is 60 and our last term is 120. Okay, so that's what I mean by A1 plus AN. It's the first term plus the last one in the pattern there. So this is another one that you're going to have to memorize, so you should be familiar with it. What I need to figure this formula out is I need to know what n equals. So when I'm looking down here, I have the sum from k equals 1 to 20. So I'm starting at the first term and going to the 20th term, and my rule is 3 plus 5k. So I need to know what n is. Well, n is 20. That's going to be my last term, because remember, the top number is the last term. A1, okay, so let's plug 1 into the formula. If I plug 1 into the formula, I get 3 plus 5 times 1. That's going to be 8. And then I need the last term, I keep saying term, which is going to be A20, because we're doing the first 20 terms here. And so I plug that into the rule, 3 plus 5 times 20, and I'm going to get 103. All right, so now that I know what these values are, I'm going to go up here and use my little rule here and say, hey, the sum of the first 20, I'm going to put little tails on my S because it looks like a 5 otherwise, sum of the first 20 is going to be 20 divided by 2, because I'm doing the first 20 numbers, so n is going to be 20. And then my first term, 8, plus my last term, 103. And then if I use, a calculator to figure all this out, or technically you don't need a calculator, the sum of these guys is going to be 1110. And there you go. All right. And if we wanted to, we could just really quickly confirm this in the calculator, because we know how to do sums now in the calculator. So I hit math, and I'm going to go up to summation right here. And I'm doing x from 1 to 20. And my rule here was 3 plus 5x. And I get 1110. So you can always check your work, even when you're using the formula to do this algebraically. Now, this one's tricky, because the things we need, right? We need to know what n is, we need to know A1 is, and we need to know what AN is, the last term. Well, we know that the first term is 60, and we know that the last term is 120, but we don't know what n is yet. So that's going to be our first process. Is we need to first figure out what n equals. And the way we're going to do this is kind of like back in the day, if I told you, when you had a y equals mx plus b, and I told you what the y value was, and I asked you to find x. It's the same idea. We're going to say, hey, when AN equals 120, what is n? So I'm plugging this into my arithmetic rule. And I did a couple things in here. First, I noticed that I'm going up by 4. That's my pattern. That's my D value. And I just did the AN equals A1, 60, plus N minus 1 times D, the common difference, which is 4. And I can now backtrack and figure out what N is. All right. So I'm going to first subtract this 60. So that's going to give me, 120 minus 60 is 60 equals. And then I'm just going to rewrite this 4 in front. So 4 times N minus 1. I'm personally going to divide by 4. You could distribute the 4 and then go from there. But if you divide by 4, you're going to get 15 equals N minus 1. And so that's going to give me that N equals 16. So I know that this is actually A16 and that there are 16 terms in this little sequence here. So when I go to find the sum of the first 16 now, I'm just following that pattern that's up there, green highlighted. So I'm going to have 16 divided by 2. The first term was 60 and the last term was 120. All right, so I'm doing 16 over 2 times 60 plus 120. So that's going to be 8 times 180. And I used my calculator to figure out that that's going to be 1440. Now, this one we can't really check in the calculator because it's not really in summation notation, but we could if we really wanted to, but it's just not really worth it, honestly, to try to check this one, unless you just have a lot of free time on your board. Alrighty, last set of your turns, so you should try this one out, and I will be here going over it whenever you're ready for me. All right, I'm just going to write the rule up here so I don't have to remember it. So this is our sum for arithmetic, A1 plus AN, and the little n divided by 2. So we have this guy. Remember, I need to figure out what n equals. I need to figure out what the first term is, and I need to figure out what the last term is. So n is going to be 12. That's the top number. A1, I'm going to plug it into the formula. So don't just look at this and say, oh, it's 2, because that's the y-intercept. Remember, the y-intercept is different than the first term. So I plug in 1, and I'm going to get 2 plus 7 times 1. That's going to be 9. And then AN, well, that's really A12, because n is 12 this time around. And so I'm going to do 2 plus 7 times 12, and that's going to equal 86. Alrighty, so let's plug it into the formula now. So I do S12 for the first 12 terms. I'm going to do 12 over 2 times n plus 86. That's going to be 6 times something. I don't know. I can't do that math in my head. But I do know that that equals 570 when it's all said and done. So this summation equals 570. When it's in this form, remember that you could jump into the calculator and double check it if you really wanted to. Now, this one, same idea. We need to know what n equals. We need to know what A1 is, the first term. We need to know what AN is, the last term. It just so happens that we know the first and the last, but we don't know what n is. So sad. When I'm looking at this, I do know that the common difference is that I'm going up by 3 each time. And so I'm going to reverse engineer what the n value is for this term here, the last term. So I'm going to say, hey, when this thing equals 29, I know my first term was 2. I don't know what n is, but I know my common difference is 3. So I'm just plugging it into the generic arithmetic sequence formula. And I'm going to reverse engineer this, right? So I'm going to get 27 equals 3 times n minus 1, divide by 3. So 9 equals n minus 1. And that gives me that n equals 10. So I know that this is actually saying that A10 equals 29 and that there are 10 terms here. So to find the sum of the first 10 terms, 10 divided by 2, first term plus last term, plug that into the fancy calculator, I get 155. Alrighty, hopefully this made sense to you. And feel free to like and subscribe, and I'll catch you in the next one. Bye.